Good afternoon. We are the Location-Aware Computing and the Hybrid Cloud Group. Let's jump right into it. Let's say a real estate company wants to use a large data set in Google Cloud Storage, such as the crime rate in California. And they want to estimate the crime rate for a certain region based on this data, say Mountain View, California. Instead of moving all the data back from the public cloud to their private cloud, it's very expensive to move around data. The company can use the outstanding performance of BigQuery to select crime data from near the San Francisco Bay Area and move this data to their private cloud for estimation. Maybe they have their own secret sauce or their own estimation model that they want to keep within their own servers. So here we come to our problem. You're running a hybrid cloud, you have public and a private cloud. You want to utilize the public cloud infrastructure as much as you can. They have a vast amount of resources, they have scalability, and this is the most cost-effective way to perform calculations, minimizing latency and costs. You'd prefer to keep your secure calculations in-house. You want to ensure computational locality throughout. First, let's talk about serverless, or Lambda functions or functions as a service. It goes by many names. First, we just had no sharing machines. Virtual machines came about, which allowed mainframes to be more efficient, more easily managed, and to allow the sharing of software over the same hardware components. Step up from there are containers. Containers are similar to virtual machines in that they provide an isolated, discrete, separate space for applications to execute in memory and storage to reside, and to provide the appearance of an individual system, although they're sharing both the hardware and the operating system. Step up from that is what we're working with, functions as a service, or serverless computing. The name can be a little deceiving. Serverless, you do still actually need a physical server, but the client is not paying for the entire server. Rather, the client's paying for only their function that they deployed there. They're only paying for it when it's run, or when it's triggered by external events. This is the most cost-effective way to deploy software, as you're only paying for fractions of a server. We'd like to utilize this function as a service. However, serverless can't really use it as it is. It needs to be a lot of work before you can make it work correctly. So next I'll talk about our solution to this hybrid cloud model. Our project aims to build a toolkit that achieves computational locality using serverless Lambda functions, functions as a service. Our project can be looked at in two main parts. The first is a Babel plugin, which can be used to transpile the JavaScript functions into a format that can be used by AWS Lambda and Google Cloud Platform. The second is a command line interface toolkit that includes the serverless CLI that allows us to deploy functions to AWS Lambda and Google Cloud Functions. So both AWS Lambda and Google Cloud Functions are public cloud providers, and Lambda and Google Cloud Functions are their functions as a service product that allow you to deploy functions to the cloud. Serverless is a framework that was created to simplify the process of deploying your functions to AWS Lambda. The way it works is that it creates a CloudFormation template, and this allows you to easily deploy on a serverless. Now that I've gone over our product, let's talk about our overall plan, how we got there.
I'll talk about our overall plan for all the 5 sprints. For the first sprint, we developed a Babel plugin for support of member functions, and for sprint 2, we have a program that can do simple deployment on the serverless and AWS Lambda. And for sprint 3, reconstruct the file structure and add some redeployment functionality and function dependencies. Also, multi-function support for our program. This is done on AWS Lambda. For sprint 4, we build a motivation ExpressJS application and enhance our CLI tool. And we also experiment on the Google Cloud function. And in sprint 5, actually can run both on AWS Lambda and Google Cloud function. For the system architecture, the customer can specify their cloud function and local function in the main.js file in their folder, and the Babel plugin will extract the cloud function JS file and build a cloud function JS and serverless configuration file for each the cloud function in a separate folder. Then the plugin can deploy the functions to serverless and get back the URI to generate the Localhost file, which can be run by the user. I'll walk through the system diagram. First, we have the main.js file. That is the user-specified JS file in their in-files folder, and you can add comments like cloud and different providers in the JS file. And you build the file which will transpile the functions into ES5 version, which can be deployed onto the AWS and Google Cloud function. Also, after that, you can run the index.js in different mode, which way actually contains three mode. That is different steps for the deployment. First, extract cloud will extract the cloud functions in the main.js file and put them into a separate folder for each function. And there is also serverless configuration file for them. There with different configurations that user can be specified. After that, you run deploy cloud command. Those functions can be deployed on which platform you prefer. You can see that after the deployment, the URI can be get back to our local.js file. So we run prepare local and get back the URL to add them in our local.js file, which change the cloud function into a request promise to the cloud providers. In that case, the function is actually running in the cloud. For the accomplishment, we started from baby steps, learn about functional as a services, and we are able to deploy functions on both AWS Lambda and Google Cloud functions. Then we also learn a lot about JavaScript. We learned Node.js, ExpressJS. We use Node.js to build the project structure and ExpressJS to build a demo application. We also learn Babel to able to transpile from ES5 and EX6, and also extract cloud functions, get back URL to prepare local.js file, all done by Babel. We also learn different configurations and structures about AWS and Google Cloud services. We're able to connect AWS S3 and Google Cloud Storage to our project. We ran the ESLint, which is standard for JavaScript programming, and improve our code quality, clean up some bugs. Finally, we are able to publish our program to NPM Origin. It's an open source platform for Node.js, and we have hundreds of downloads by now, which is good. Next, we'll show a demonstration.
So let's start with a demonstration to show what we can do with our project. So let's suppose that the user has two datasets. One is in the Google storage and the other one is in the AWS S3. So if user want to make some queries to Google storage, so he want to get some data from Google storage, and at the same time he want to do some computations on the data in the AWS S3. So without the help of our project, he has to do all those things from local, which means he has to make queries from localhost to the Google storage. So there will be many communications back and forth through the firewalls that will cost a lot of time. And also for the AWS S3, he has to get the data first. So the data can be really large, and also he has to do all the computations locally, which is not desirable. So ideally, we want to do all the queries and the computations at the same place with the data. Means we want to do the computations near the data, so that saves a lot of time, right? So now with the help of our projects, the user don't need to know anything about serverless, about the AWS Lambda. So he don't need to change anything. He has to add 2 to 3 lines of comments on the top of the function, and all the code will be prepared and deployed to the corresponding place. So let's do a simple demonstration to show how we're gonna do this. So now I'm in the folder of the project. So the user can run just npm run all, and all will be done. So the files now is in the source, and after run this, all the code will be prepared and deployed to the cloud. Okay, so it may take some time, so let's go back to the PPT. Okay, let's have a close look to those functions. So at the left side is the original files. So this is for AWS. So the user is trying to get some data from AWS S3. So you can see there are some bucket key names, and also you can see like after getting the data, he want to do some computations. So in our example, we just choose a simple computation. We compute the average, but in general, you can do whatever you want. And after get the average, he just want to send it back, right? And so the user want to deploy this to the AWS, which is ideally. So the user just need to add annotation of cloud, and he can say, okay, we want the provider to be AWS, and we are using S3, and we want to be deployed to the US East 2, which is a region. So these parameters actually are optional. So if you don't provide this, we will detect or choose it by default. And the right part actually is the transpiled version, so it is the prepared version. So you can see there are a lot of difference, like we have to use event trigger, event callback model, and we have to pass and get back the results through JSON, and then we need to pass all the objects through the event, and also we need to change it to callback. There are a lot of difference, and it's all will be done automatically. And so in this example, we just pass one object, but actually you can pass as many as possible as you want. So this is AWS Lambda, and for Google, actually Google Cloud Function is more tricky because he requires the project name and the credentials. So we let user pass it through the comments. So for credentials, you cannot pass credentials in the code, right? That's crazy. So we just pass it through the path, so which is much better. And you can see like the model is different. So for Google, we use a request response model, and we also pass it through the request, and there are many different requirements, but we can handle them separately, so the user do not need to know anything, but it will be done automatically. And then for local, so after deploying the function to the cloud, instead of running the codes in this for this function locally, we will now make a request to the cloud. So you can see like the function, for example, this is originally is the Lambda function, is the AWS function. So we make request to the cloud path. So this path is what we just get from the cloud. So we know like this function now is be placed to this path. So we just make a post request and get through and pass the parameters through the body, and we will know the response. So that is same for the Google. And okay, let's see if it is done. Okay, it's done. So we run a simple we write a simple ExpressJS app to show you the result. It's just for demo, but you can consider all those functions. So you need a lot of functions for ExpressJS app, of course. We can consider all those functions are just local functions, which means the user choose not to deploy them to the cloud. So now let's see, we can run it locally, yes, and we can see if we press this run Google Cloud Function. So you see we make some queries at Google instead of locally, and we just pass the result back. And for AWS, yes, we can get the result. So those result, this computation is done at the at the AWS Lambda instead of locally. So you can see the consoles, yes. So we get them from the cloud instead of locally. That will save a lot of time in the traffics. And so this is just a simple demonstration, and we have published our project to NPM Society. So if you want to see more details, more examples, you want to play with it, you want to see more introductions, so you can go to this link, the NPM Society link. And surprisingly, actually, we have got over 400 downloads in last month, which is we are really proud of. So it means there are hundreds of people now is trying to use our project. Yes. So then let's so now that's all of the demonstration. Now we can change to the challenges.
So some of the challenges we faced with respect to the project are learning different requirements for AWS Lambda and Google Cloud Function, which are the two serverless technologies we've used. We'll talk about more about that in the next slide. Using AWS S3 and Google Storage, which are two different technologies, and asynchronous programming with Node.js, we had to use callbacks and request promise to be able to get the correct sequence of events. We'll talk more about that in the next slide. And generally learning more about the Babel plugin file structure and working with the abstract syntax tree. And the challenges with respect to AWS Lambda and Google Cloud Function was that both of them have two very different structure and requirement. And some of the differences are that AWS Lambda, there's no need to create a project first. The serverless automatically does that. Google Cloud Function, you must create a project in the Cloud Console before using it. And AWS Lambda needs a root access credential. And for Google Cloud Function, the credential key file is added. It needs to be added in the configuration in the file.
Yeah, so basically you have to pass your credential key file path in the code. So that's the requirement of Google Cloud Function, but in AWS it doesn't require that. It automatically tags your credential folder. So there is a big difference between them. So we have to design to do two different ways to deal with different situations.
So AWS Lambda would automatically take in the credentials from your login, as opposed to Google Cloud Function, which you would require to send the key file path in the code that you see in the annotations as a part of the comments. AWS Lambda has a dedicated API for S3. For Google Cloud Function, you need to use HTTP request to connect to the Google Cloud Storage. AWS Lambda gives out the input-output format in JSON, and you need to use the callback function for it. And Google Cloud Function would use the request response model to be able to trigger the function to be able to use it. The challenges with respect to asynchronous programming with Node.js was that the program needs to run at a certain sequence, and some examples for this would be we needed to extract the cloud first, generate the configuration file, and then deploy it. All of this needs to be done programmatically and at certain times after the result from each has been received. And another example would be the shell script for getting the URI for the cloud functions. Some of the tools that we use is callback functions and promise resolve model. And one of the challenges was to be able to use them together. The future work would be checking for self-contained cloud functions to make sure that it doesn't use other functions within that file, and the function does not depend on any other parameters or other functions other than everything within the scope of that function. Additional testing with respect to having multiple functions and files, support for more cloud providers as and when the technologies come out, and increased functionality in general and more testing. What we've learned from this project, with respect to technologies, we've learned about the function as a service model. We've learned how to use Babel to be able to recognize file structure and extract bits from it and to be able to transpile it. ExpressJS and Node.js to be able to build the app. ESLint to be able to clean the code and make it presentable, readable, and usable. Serverless is the main technology that we were trying to build around and trying to leverage. And for teamwork, we've used agile development and consistent development schedule. Trello helped us keep track of all our tasks, and having deadlines on Trello helped us to plan out to start work early, the division of work. And use Slack for communicating and helped us be more productive in general. These tools helped us to be able to meet regularly and with our mentor to be on the same page that we understand and are developing the technology that we envision to develop. And hopefully we've done just that. Thank you.
Please feel free to contact us through our emails down below, or you can check us out at our GitHub and NPM pages. Thank you very much.